Well, you coming?
Where?
Why, to the North Pole, of course.
This is the Polar Express! All aboard!
Volcanoes. For as long as Earth has existed, volcanoes have dominated its landscape with eruptions of great force and smoldering lava. But one has to wonder, what causes such power? What makes volcanic eruptions so destructive? Modern sciences have showed us how, and that's what we're here to find out. So to get my volcano facts straight, I went to ask some questions to the volcanologist, some random guy I didn't know. So, you're the guy for volcanoes?
Yes, I am the guy.
Can you tell me what causes a volcanic eruption?
Well, the three things that determine the violence of a volcanic eruption are temperature, water levels, and viscosity of the magma. You see, high temperatures in the magma evaporate water contained in it, which then forms gas bubbles that build and create pressure within the volcano. Then, determining the viscosity of the magma determines how much gas or pressure will build up inside the volcano before your eruption. The higher the temperature, water levels, and viscosity of the magma, the more violent the eruption will be.
One thing I found interesting about our interview is that not all volcanic eruptions are the same. In fact, there's multiple types of volcanic eruptions that I wasn't even aware of. The types of eruptions varied from small scale and practically harmless to catastrophic. The first volcanic eruption me and random guy discussed was the Strombolian eruption. These eruptions usually occur in smaller volcanoes containing basaltic magma. Random guy explained the eruption more in depth. So what's the process of a Strombolian eruption?
Well, you see, bubbles form in the magma chamber around down here. Then, those bubbles merge together, forming bigger ones that eventually rise through the vent up to the top of the crater cone. Then, because of low air pressure, the bubbles burst, basically spreading lava throughout the area.
So this isn't even really like an eruption, more debris from a pop bubble.
Yeah, basically. It's still an eruption, it's just a very minor one.
After our interview, random guy offered to show me a real Strombolian eruption. Is this safe?
Oh yeah, you can come on in. Trust me, I'm a professional. I mean, it should be coming up any second now. Ah! 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 It burns! Call a medic!
Estamos viendo una erupción del volcán Santiaguito. Sigue elevándose, sigue elevándose, sigue elevándose. Genial!
The second eruption that I learned about was the Volcanian eruption. Random guy explained that this is when a dense cloud of ash blasts out of a volcano, rising dozens of kilometers above the peak, like this eruption here.
Está saliendo con fuego del lado izquierdo de la fumarola.
Okay, so this is how this eruption goes down.
Ash, lava fragments, and dust collect in the crater cone of the volcano. Then, when pressure builds and it erupts, there's a chain of explosions launching the lava fragments through the air into nearby valleys at incredible speeds. Then, ash, gases, and dust collect in a huge cloud that then disperses into the atmosphere. So this isn't one of the fiery and destructive eruptions we think of. Yeah, I would say that.
Your commentator is Robert Stevenson. Vesuvius explodes. Italy's historic volcano bursts into the most fearsome and devastating eruption in 70 years. Over the fiery crater, a great pall of smoke and lava dust spirals into the sky, a giant specter of endless grief for the Italian people. Suffering under many years of brutal fascism, then German occupation, then Allied bombing, then the devastation of battle, now it is Vesuvius.
Finally! Now we're getting down to business. Some real eruptions. A Vesuvian eruption is when great quantities of ash and gas are violently discharged from a volcano, forming a cauliflower-shaped or mushroom cloud above the volcano.
Rising 4,000 feet above the fertile plain of Campania, Vesuvius lazily pours forth a harmless curtain of smoke.
The ash then rains down surrounding countryside of the volcano, and rhyolithic lava runs down the sides of the volcano, covering the area.
Then, with a few warning rumbles, Vesuvius belches fire, flame, and molten rock in a fearsome spectacle. Tons of ash and cinders are borne skyward, while fiery lava streams down into the doomed valley. The overflowing crater erupts with a mounting temperature of liquid steel close to the summit, which carries its fiery heat long after it loses incandescence.
So this is one of the more large-scale eruptions.
Oh yeah, definitely.
So this is how the eruption works. Every time this volcano erupts, a bubble or mass of lava will form a hardened seal on top of the volcano, which means as well as the volcano building pressure from trying to break the resistance of the viscosity of the magma, it also has to break this seal on the crater cone. And that about takes a century in time. So every century, it'll build up enough pressure to break this seal. Then the seal will shatter into pieces into molten hot rocks, and it will scatter all across the countryside of this volcano. As well as that, a mushroom cloud or cauliflower-shaped ash cloud will form above the volcano, and rhyolithic lava runs down the sides. So it's basically complete chaos. I hear there's a similar eruption called a Polynean eruption. Yeah, a Polynean eruption and a Vesuvian eruption are very similar, except for the fact that a Polynean eruption is in fact more violent than a Vesuvian eruption, and actually has debris and lava running down the steep sides of the volcano at over 700 kilometers per hour, which is dangerously fast. The last eruption we discussed, the Polynean eruption. Okay, so this is our last eruption, and here's how it works. Ash, dust, and lava fragments are erupted from the central crater or the crater cone of the volcano. And then when the minerals and fragments fall back down, they roll down the sides of the volcano at about 150 kilometers per hour. This kind of eruption is also known as pyroclastic flow. Now, you may be wondering why we didn't have any footage of a Polynean eruption. Well, this is because even though the last trip to a volcanic eruption didn't go quite as planned, random guy wanted to make it up and try and take me to see a real eruption to behold. Are you sure this is going
Yes,
to
I'm positive.
I'm just worried because it seems like last time things didn't really work out.
Oh my god. Look at Bob. See how happy Bob is? How can you doubt me when Bob looks so happy? God. See, look, we made it. And not a scratch on us.
Yeah, you're right. I guess I just overreacted.
See? You gotta trust me more. Warning! Warning! Eruption alert! For all of you 1,500 miles away, you still have a chance, but for those of you at point blank, kiss your ass goodbye.
I hate you!